Hi everybody, Patricia Worby here, and another in my ongoing series of discussions with my friend and colleague, Dr. Rainer Viehweger. And today we're going to be talking about the fundamental fractal and applications in the therapeutic world. And I'm terribly excited to hear this one, Rainer. So do explain to me what's so fundamental about the fundamental fractal.
Yes. First of all, I'm also happy to talk to you again and to spread the word on the global scaling law, which I love so much. And yes, we heard everywhere that fractals appear in nature at every corner. That people find them in plants, people find them in coastlines, people find them even in the human body a lot. So the branching of the bronchi in our lungs follows a fractal distribution or a fractal pattern. The branches of the arteries in the kidneys, for example, follow a fractal rule. And maybe first of all, we could talk about how a fractal is created.
Good idea.
And what a fractal really is. It's very interesting. I learned that every organism and every cell even, which is also the smallest organism we know of, is a standing wave system, which means it is a kind of a certain cavity-like structure which has an outer boundary. And this is how a bacterium looks like. This is how a cell looks like. Even a small ball-like virus looks like that. Or a ring-like, a donut-like virus would look like that. But the seeds of plants look the same way. And even our whole body is, we could consider it as a cavity. And inside those cavities, we find smaller cavities, just like being organs nested in the organism, and then cells nested in the organs, and organelles nested in the cells, and then bigger molecules nested in the organelles. And that goes down to the atomic scale and subatomic scale, but it also goes further up in the scale because our body is nested in the atmosphere of the Earth. And then the Earth again is nested in the space of the solar system and so forth. So we find this embedded structure everywhere in the universe. And it's very interesting. When I read the book by May Van Ho, which is called The Rainbow and the Worm, I couldn't find out what that title would be about until I read the book, really, because it has a lot to do with organisms being standing wave systems. Because what they have found is very interesting. They were looking at small organisms just like cells, and then later they also had looked at worms. And what they found under the polarizing microscope was that the light that was reaching that cell or the worm was broken into its light spectrum of the rainbow. And what you could see was the rainbow spectrum of the visible light, which only happens when you look at a standing wave system. So that breaking of the different wavelengths into of the white light into the wavelength of the different colors only happens if you have a system that is made of standing waves.
Oh,
And that's very interesting. And it reminded me of people saying that we have the 7 chakras and that they all relate to the colors of the rainbow. So it starts with the red for the root chakra, goes through the rainbow colors, and ends with the crown chakra in purple on the other side of the spectrum. So that's very interesting, and it shows that also our body is made of the same self-similar structure as its cell, or even as a smaller organism like a worm or something like that. There is self-similarity in the organism, in the cell, in the structure, and this self-similarity seems to be really universal, and we could see this as kind of a unifying physics law for a unifying universal field structure. And what we need to know when we talk about fractals is something that is probably easy to imagine. A fractal is a kind of a fraction of something. So a whole has to be broken into some pieces, or you have to have a whole thing of which you take out some fractions. And what is left is a fractal structure. And the size of what is left is called also the fractal dimension. And this was introduced by a mathematician, and his name was Hausdorff, and that was over, I think it was about 100 years ago. So the fractal dimension would give us information about the size of the fraction that was taken out of the whole. And if we think of a 3-dimensional cube, and that maybe is a piece of cheese. If we think of Swiss cheese, then they have holes in this cheese. And the size of the holes would give us information about the fractality, about the fractal dimension. So is it lots of smaller holes, or is it a few of bigger holes? And this is what's very important to understand fractals. And also, it's only fractals that enable us to live here. Because if we would like to enter a house, and that house would be solid, we could not go in.
no, that's true.
So a fraction of the inside of that, what is the house, must be taken out to create a cavity inside the house where we could move in and move inside that space of the house, that we can be another cavity inside a bigger cavity, so that we could be nested in the house. And it's the same like with a bird's nest. So the nest of the birds must create that space for the eggs to be in. Mm-hmm. If the nest would be a ball or something, the eggs would not have, could not be able to find the space they need for where they have to be. And this is also related to a fractal structure. So we always need to know that out of something, a fraction has to be taken out. And there are 2 rules that create the fundamental fractal that is used in global scaling. And one rule is that all the numbers that are used on the logarithmic scales come in the form of so-called continued fractions.
Mm.
And those continued fractions, and I will show some images of continued fractions as a representation of numbers in the recording that we want to publish. A continued fraction is something that can represent the value of a number as an oscillation. So we would see that the nature of the number is an oscillation.
Mm-hmm.
And these numbers can also be transformed. So those continued fractions can look different in the numerator and in the denominator structure, but the value would actually be the same. This is, I know it sounds very complicated.
Yeah, you have to see it really to
but
understand it. Yep.
I will try and explain it when we look at the images. But what is here? You can see how Euler's number E can be written in two different ways as a continued fraction. The fraction on the left shows us that we have the number 2, and then we add 1 per 1 plus 1 per 2 in the next level, and then plus 2/3 and plus 3/4 and plus 4/5, always on the next level, then 5/6 and so forth until infinity. This is showing us an interesting fact that we see in the numerators, but also in the denominators, all natural numbers. And this is just an amazing fact. So we can see that all natural numbers are part of that very harmonic number E. On the right, we have a different structure of how Euler's number E can also be represented. And here we see, especially in the denominators, we see a very symmetric structure that shows us 2 per 1 plus 1, and then we can see only in the denominators a pattern that says 2, 1, 1, 4, 1, 1, 6, 1, 1, 8, 1, 1, 10, 1, 1, and so forth until infinity. So it shows us also that Euler's number E is a transcendental number, but with a very high degree of symmetry in its inner structure. But what is important for the fundamental fractal is that once we can use the nominator 1 in the continued fractions, where all those partial nominators on every level of the fraction would be a 1. And that is called the canonical or form of the continued fraction. And then there is another fractal that looks a little bit different, that is using the number 2 for all the partial nominators. And it seems that the fractal with nominator 2 is used by most of the real material processes in nature, which is not only a mathematical law, but is also materialized everywhere in nature. And there are some areas which overlap with the fractal that uses nominator 1, which is a clearly mathematical rule of how attractive areas in space-time are created, or in a level, on a scale, which is totally independent of any space and time, so which is beyond space and time in a in a timeless world. And what we mostly will talk about in our examples today is the fractal, that part of the fundamental fractal, which uses nominator 2.
Okay.
And this is a fractal which is basically the fractal that was created by Georg Cantor. And I don't know if you have
I've heard of him. Yeah.
heard that name. We will also display this this Cantor, how he created the Cantor dust. And I think that was in the 19th century. And this is, why is that so important? Because this is the simplest one-dimensional fractal that can be created. So one dimension is a line. 0 dimension would be a dot. It's not possible to divide a dot really into something, but you can divide a line into something. And what he did was that he divided a part of that line into 3 equal pieces, and he always removed the piece in the middle, that the 2 equal pieces on the left and the right side remained there. And then he took those 2 pieces and he divided them again into 3 equal pieces, took out the piece in the center. And then with the remaining pieces on the 2 sides, he did the same again and again and again until infinity. And he ended up with an infinite amount of dots, and that was called the Cantor dust.
Wow. Okay.
And this structure is used also by nature in a very interesting way when real physical processes come on a very harmonic level. They follow the rule of the fractal that was created by Cantor. And we could imagine this whole thing as a waveform traveling on a one-dimensional line from the beginning to the end, and then being reflected and coming back and going back and forth again and again, like fractals are created in mathematics with repetitive calculations, which they call iterations. So it happens, the same thing happens again when a wave is traveling on a line, reflected at the end, at the boundary, coming back, being reflected at the first boundary again, and creating a standing wave system. And when a certain amount of energy is in that system, the distribution of the harmonics creates that fractal, which is the same fractal structure that was created by Georg Cantor. And all those little oscillational nodes, which we will find on that standing wave system, are areas that attract matter, where it would condense. Because when a waveform travels on a line, it has the oscillational nodes and it has the antinodes. And in the antinode area, which is the middle part that was always removed, there is no attraction, because the oscillation would remove everything from that space which is there by going up and down. And if there were poles on the line, all those poles would be attracted to the oscillational nodes. This is where they would concentrate.
Mm-hmm.
And this happens not only with the first mode of the waveform, but also with all harmonics. Smaller and smaller and smaller, but creating always the same pattern. So following that fractal rule of self-similarity.
Mm-hmm.
And when we look at the fractal structure on the line, then we see all these different areas with the nodes and the gaps, and all those little nodes and bigger nodes and smaller nodes, the subnodes, they are attractor points for matter condensation,
Mm-hmm.
for density of something that concentrates. And that could be mass, that could be wavelengths, that could be even time. So event density as well.
Mm.
It could be pressure, it could be temperature. So everything that we can somehow relate physically in a physical manner to a property of the proton or an electron will follow those rules. And then we would see the density distribution on this line, on the scale, for how matter would organize itself in the whole universe over the whole width of the scale, from the smallest subatomic areas up to the biggest cosmic areas, self-similar as above, so below. We would see in the same way, but only in a harmonious way, on the level of using least energy that is possible. And that's so interesting. This fractal structure is always created whatever happens somewhere locally where you could use more energy and bring something into vibration with a big amplitude and cause ripples somewhere. Then over time, the pattern to which it would return follows again the same fractal. So this kind of fractal structure also needs time to be created. And it's always a local process. So whatever happens, and it may be even our birth, the birth of a human being, is something that initiates a new process of growth in time. And then we know that the growth of the organs of a baby, it's just totally different than the behavior of the organs in an adult. So the physiology of a baby works on a totally different energy level than the organism works when it became an adult organism.
Is that a product of the sort of time?
Yeah, time
process.
Time is also involved in that. Yes.
Yeah.
And time, the time fractal would determine, because it's calibrated with the superstable oscillations of the protons and electrons in the atoms of which the system is made of. That's why these oscillations determine the behavior of the whole system. Then there are areas when the system meets during its growth in time, when it meets those oscillational nodes on the fractal scale. And on this areas where we have the biggest fractal nodes, the resonance with itself is highest. So there's always an attraction towards the point, which is compressive, or it is building structure and building compression. So it builds structures, and then it gets to that oscillational node where it experiences a 180-degree phase shift. It's like it goes through the eye of the needle. So before you come there, there's compression. You have to be compressed, and then when you go through it, you can extend again. So there's a decompression. There's a whole shift of all kinds of properties. So we could say on the side before it happens, that's neck entropy. And then it has the 180-degree phase shift, and then it becomes more entropic. So there's compression and decompression, compression and decompression. So it's like a yin-yang kind of rhythm.
I'm wondering if that's what death is.
Yes, it is. It is.
Going through the eye of the needle into a phase shift.
Yeah, that's how actually I think what happens, because what people observe just before some people die, that there is a kind of a constancy in physiological rhythms,
yes,
which exactly meet the rhythms that are represented by the oscillational nodes on our scale.
Wow.
And this is for two reasons. One, that kind of eye of the needle, so the oscillational node, seems to be a point from which you can change dimension, where we probably can leave our body. But from a physiological point of view, and this is how we will meet it again when we talk about therapy, in those oscillational nodes, when we find a physiological rhythm like breathing or heartbeat exactly in the node, that means that organism is so weak already because it has only the energy to run on lowest level using a frequency that needs least energy. And this is, for example, 67 heartbeats per minute. And this is what is also observed in intensive care units when there is a very stable heartbeat.
It's a problem, isn't it?
Then it's a problem. And when it comes to 67 beats per minute, it is time to know that this person may really die in a very short time. And there's also a Chinese saying, an old Chinese saying, which says from traditional Chinese medicine, when the heartbeat becomes constant, you come closer to death. So it didn't say anything about the heart rate, really. But this is always a bad sign when something is constant. And when it's really in that node area, that means the system cannot adapt to higher energy demands anymore.
Yeah.
So it really has lost a lot of energy. And this is something we can learn from analyzing processes according to the rules that are given by the fundamental fractal. So we can measure things, and we can take the data that we have measured. We can look where they are represented on the scale with the density distribution.
Mm-hmm.
And then we would see, is it in a compressive zone? Is it more healing? Is it more decompressing? Is it more entropic? Is it more system destroying, expanding? Or is it in a node area where the probability for it to change is also very high? And it could also be that they are gap regions on that scale where there is no resonance with itself. Then it doesn't want to really change a lot by itself. So then we may need more energy to make shifts.
Okay.
Yeah. But on the other hand, when our lifetime is in such a gap area, then if we want to initiate something new, a new project or something, that doesn't really or would not really resonate with us, because our internal resonance is on the lowest level at that moment. And then if we start a new project, it's always taking a lot of energy, and then you probably will not really succeed with it. You put more energy in it doesn't want. And then a few months later, or a few weeks later, it just, you only think of it and it happens.
So it's like putting things in place in the right resonant
In the right,
moment.
Yeah. You can also use this fractal and look at the age of a client, and also look at the age of a disease process. So when did it start? Or when was the accident? When did the trauma happen? Whatever it is. And when I look at the person's age, and when I look at the age of the disease process, in what state are they in relation to each other, but also in what state are they? How can they be influenced very easily? And it may be that even appointments from one therapy session to the next could be in a rhythm that is beneficial to go on with change in the client.
Well, I don't think anybody discusses that.
Yeah.
Really.
Yeah. There were some people who have done that before, knowing about the global scaling rules. And this is also a very interesting application that could be used. But this is not only true for therapies. This is also when you do some, if you want to do some marketing, or you want to sell something, when would you have a follow-up call to keep people interested or something? This is, it's the same rule.
Okay.
There are so many areas of where it could be applied.
Yes.
Yeah, once we know, more people would know about it, maybe things at the end would be more effective than they are today, because most of these things are done randomly today, or they were figured out through experience.
Yeah.
Because we know, even in marketing, there are rules which were found that things, if you do it that way, it normally works well. With the application of the global scaling knowledge, you could find out why this is the case, and you could also probably optimize it.
Yeah, that's amazing.
Yeah, that's amazing. So when we think about therapeutic approaches, we would mostly use biological rhythms. So physiological rhythms in which we would do something with our clients. We would not go into body size because we don't want to change the skin surface of our bodies, which also follows those rules. But we may want to change body weight. Mm-hmm. That could be something. And how our body weight develops is also following the fractal rules.
Oh, okay. Tell me.
Yeah. So when we reach a certain body weight, it will be harder to change it. As soon if we meet the attraction of another bigger attractor, for example. Yeah, so let's see if I can find some an easy example here, which we can also play in the recording later. I only want to go to kilogram now and put in 70 kilograms and see where this is. So we are now very close to a big oscillational point in global scaling, which is 66, and we find 66 at 77 kilograms. So this is something where probably men would be easily attracted to this body weight when they have a certain body height.
Right, a body height, did you say?
Yeah. So it would be for a woman with a much lower average body height. 77 kilo would be probably a little bit too much.
I see. So she would hate that being that weight. Yeah.
Yes, of course. And we would, from a physiological point of view, we would also, if a woman is 163 centimeters and would weigh 77 kilos, she would be overweight.
Yeah.
Yeah, but if you have a male person just like 185 centimeters, 77 is just ideal.
Ideal, yeah.
But nevertheless, independent of that, we could go through all these little subnodes here, and there are even different ones which not only have proton resonance, but also electron resonance, where things like to stabilize themselves. So they are even more attracted to it. Then there is something where you would say once you reach a body weight of, let's say, 107 kilo, going down from that needs more effort. You probably would be able to go easily down to 104, which is the edge of that subnode. But then leave it and even go further down would require, again, more effort.
And is that different for each individual, or is this for an average person? Because
this is for most
men and women.
This is for most average persons. Yeah. Because this is in general related to body mass.
Yes. Okay.
Which is made of protons.
Yes.
So most of the mass or of the weight is proton mass. More than 99.9995%, because the weight of electrons is only 1,836 part of a proton. So we really weigh our atomic nuclei and not the electrons.
Okay. So there are
Yes, and that
certain
would be true
notes.
for everyone. Yes.
Yeah, okay. It's just men and women are obviously different weights, so I
It's
guess.
it's a little bit a different weight, of course, and
Yeah.
that would go to other subnotes for men and women.
Mm-hmm, mm-hmm.
But
Okay.
then, how easily you will be able to change your weight
Mm-hmm.
is only depending on that scale.
Yeah, that's, yeah, again, I
Yeah.
don't know anyone who's ever spoken of this really.
No, not because
It's unusual, isn't it? A way of thinking.
It is, yes, it
Yeah.
is. And there are so many nice things, you know, breathing exercises,
Mm-hmm, mm-hmm.
the breathing with least effort for an adult healthy person
Mm-hmm.
is breathing in and out 15 times a minute.
Mm-hmm.
Around that, it could be less or more. And we all know when we need more energy and we are under stress, we breathe more often.
Yeah.
And that and this is decompression. So we want to free energy. But if we want to build structure or want to regenerate, we used to breathe in a slower rhythm.
So more energy, we breathe faster, and for renewal and regeneration, we breathe slower.
Yes.
Which is what happens during sleep, of course,
Yeah.
doesn't it?
Yes, of course. That's what we're doing. So we can always say that on the scale, we would find the respiratory system in one of those notes, and the next note in the neighborhood would be the heart rhythm, which, by the way, is part of the delta range of brainwaves.
Yes, I've heard that.
So there are times overnight when the heart rhythm and the brain waves are synchronized.
Okay.
Synchronized.
Mm-hmm.
Which again needs less energy, but also when they work in the same rhythm, there's a maximum of information exchange possible because they are using the same wave on which the information can travel.
That makes a lot of sense. Why good sleep needs that delta range rhythm.
Yeah. Yes.
So more information.
Yeah. And then the heart would transmit the information that it has received from the brain through the circulatory system to every cell without using nerves.
Wow.
And we know nerves deliver electrical impulses, but the heart delivers sound and pressure waves.
Yeah.
That would have the same frequency and would be more energized.
So the heart has an electrical system, though, doesn't it? It does use nerves.
Yes, it has it builds an electromagnetic field, but it also creates a pressure wave and a sound wave.
Yeah, it does. You hear the heart, don't you? So yeah,
that's what the heart does. The next node would be the main node for the brain, which is at 5 hertz. Okay. And 5 hertz is the theta wave range.
Theta, yep.
And this is also a very important boundary condition. So when we go below 5 hertz, we are in that compressive area, that is building structure. And above 5 hertz, that means we are freeing energy that we want to use. But it also means that below 5 hertz, we are asleep.
Yeah.
And above 5 hertz, we are awake.
Mm-hmm. Yeah. I wonder if that's how anesthetic works, you know, to switch us into the different boundary. Because
Yeah, I don't know. Would be interesting
they
to
really don't
watch an
know.
EEG
They don't
under
know how it works.
anesthesia.
Yeah, it's very interesting. Yeah. Mm. Okay.
And 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 there are many more things that can be used.
Yeah. Yeah.
But what we also can know is, because all these things are connected to each other, because there's a wave traveling from one node to the next.
Mm.
If we breathe slowly,
Mm-hmm.
we can bring our heart rate down at the same time.
Yes, we can synchronize. Yeah.
Yeah. Or with that, we also would bring blood pressure down, because that will all shift on the scale to the left.
Mm-hmm. Mm. Okay.
And it makes a lot of sense. And this is what we also know. Yeah, when we need a lot of energy, when we do exercise, then the heart rate goes up, blood pressure goes up, we breathe more often. So all goes to the other side.
Yeah.
And everything is connected in the body.
We know this. Yes.
Yeah. And there are so many interesting boundaries that you could find. A heart rate below 40 beats per minute is an indication for a pacemaker.
Ah.
And that boundary you find in the fundamental fractal.
Mm. Yeah, my mum had one fitted. Yeah. So, wow.
Yeah, the cardiologists call it the Adams-Stokes syndrome.
Ah, okay.
Yeah.
Okay.
When the heart has totally lost the connection to the sinus node.
Yes.
And there's no control anymore.
No.
Then you need an artificial pacemaker.
Oh, that's so interesting.
To be able to mobilize more energy. And then, of course, we know that athletes have a very low heart rate. But we also know that they are very often a little bit off physiology, of average physiology. And this is also something that nature provides. So there are always some flexible boundaries in which we can live. And not everybody is an athlete.
Certainly not.
Yeah.
Yeah.
Yeah, the other things, let's talk a little bit about applications. So when we can apply rhythms, that means frequencies. So when we look at light, for example, we talked about the rainbow before. And again, you find the rainbow in a certain area that is called a green area on the fundamental fractal.
Okay. In the range of light frequencies.
In the range of light frequencies. And then the range of one of the bigger nodes is in the IR range for infrared light, for heat. And the next one on the other side of that area is the ultraviolet. And that's also very interesting because there is a node at 277 nanometers.
Okay.
And this is a wavelength that is absorbed by hexagonal water structures. So isn't that interesting that such a main node wavelengths of ultraviolet light resonates with the hexagonal structure of structured water.
Structured water, which is arranged.
Yes. Yeah.
We need to just explain to people, structured water is biological water, isn't it, generally? And well, it's water that's structured differently from what we imagine water just to be H2O. It's got a crystalline, almost liquid crystalline structure. Yes.
It has a crystalline structure, and it's basically a hexagonal structure. And the same frequency range is used by those ultraviolet photons that the DNA is emitting.
Okay, that's opening up a whole new discussion. Yep.
Yes. And then it's interesting again that in that area between the two nodes, there is a very harmonious area that is called a green area. And inside those areas are still two different subnodes. One is in the green range and the other one is in the red range. And those wavelengths correspond to photosynthesis, which is the green, where magnesium is in the color active molecule. In the chlorophyll. And this structure we find in our blood again.
We do.
Where it's called the HAM. And then there's not a magnesium sitting, but an ion is sitting, which gives it the red color. And they're both related to exchange of oxygen. Yeah, one is taking up oxygen, the other one is releasing it.
Releasing it. Yes. Yes.
Yeah, and here nature uses these subnodes to make these processes easy going. As easy as possible. Yeah. And then we can also see from the distribution of those colors how the red color is helping to build structure, to regenerate, where the green color is more calming, neutralizing.
You're coming into color theory here, aren't you, as well? You know.
Yes, of course. And that's why we call the red the warm color, and the blue on the other side is the cold, and the green is the center of it again.
Wow.
Yeah, so then also from this point of view, we can, because red is more structure building than orange or yellow on that side. And the deep blue is more cooling than a more greenish blue or something.
Yes, that's along the spectrum.
And then the purple would be the coolest of everything.
I know there's a whole therapy around colors. So which ones to kind of interact with depending on what your needs are. So that would explain it.
Yeah. And because we have an area on the scale which includes the spectrum of the rainbow, we could go further down on the fractal scale because it's similar and self-similar. And we could come to the range of, let's say, sound waves and acoustic waves, which we can here and use as sound therapy. And we could easily calculate, and this is also done mostly by using octaves to bring it down. But in global scaling, you can use a different factor to scale it down into the acoustic range that you want to use for sound healing. And you will find the same density distribution of useful acoustic frequencies that you could apply, as you would find it in the light spectrum.
Gosh, right, okay.
Yeah, so this is all amazing information that I hope in the future will be applied a lot more than today to make many therapies even more effective than they are as frequency therapies even today. Yeah,
I mean, we are beginning to explore that now, but we're still at the very early stage of understanding it, I think. But but that's fascinating. Thank you. That's opened up so many thoughts in my mind. I don't even have time to ask all the questions, but I think we'll probably draw a close there. And obviously people can contact us, and we'll put all the contact details beneath.
Yeah.
As usual. So
yeah, I would also be interested when any therapist who is trying to develop a frequency therapy pattern or something could contact us. Brilliant. And maybe it would be possible to work together on working out the best patterns that could work for treatments. It's also a possibility.
Great. Yeah, great idea.
Very, very interesting.
Yep, I know people are working on that, you know, but usually privately.
Of course. Yeah.
So yeah, let's get together and get some more understanding of what we're doing and why we need this. Yeah, well, thank you. That's just fascinating, and thanks for your time. And as usual, you've brilliant understanding that I just don't hear anywhere. So okay, all right, well, we'll say thank you very much, and we'll talk again soon.
Thank you, Patricia. It was always nice as always. Thank you.
Thank you.